Good afternoon all. I'm going to build something on breadboard today based on a 555 and a 4017. These two were on this little board that was, what was it called? Detonation lamp flash, something or other. And it flashed these LED lights. I think there's blue, white and red. It was kind of like a police car thing. But anyway, what I want to do is I want to use a 555 and a 4017 to do a Nightrider thing where the little red light moves backwards and forwards on the front of that funny American car. What voltage are these? There's a plus on there, so I'm putting plus of this battery on there, but they're not lighting up. Yeah, I think that American car was a Pontiac or a Chevrolet or some funny thing like that that we Brits have never really heard of. Actually, that's not entirely true, because I had a Chevrolet Camaro. I had a 1974 Chevrolet Camaro when I was a kid, and it cost me pretty much every penny. This isn't going to light on 3 volts, is it? No. Right, you can see how we've got 4 LEDs in series and some resistor. Tell you what, maybe that'll work on 12 volts. Positive. Oh yeah, that's white. Red, oh that's quite bright, probably because of the lower forward voltage. And blue, yeah, fine. Yes, it cost me every penny I had for petrol. I was forever in and out of petrol stations, and I drove it around on bald tyres because I couldn't afford to replace them. And then in the end it was just stupid and I got rid of it. Right, so for this I'm going to need a breadboard, so I'm going to use this 400 tie point breadboard. These are my favourite ones, I think, because these little clips are a bit easier to shove into the receptacles than the sort of dovetail ones you get on the larger boards. So yeah, I quite like these. So let's get the 555 and the 4017 on there. I suppose the first thing is to get the 555 flashing an LED. These are really tricky to get out. These I don't like these sockets, these sort of leaf type sockets. And you lift one side and then the other side sort of goes back in again. It's really irritating. They just don't want to come out. No, I prefer turned pin. Turned pin are much easier. Right, there's the 4017. Actually, I don't think I'm going to take the 555 out of there because I'm sure I've got loads of these in some drawers. Let's zoom in and use some illumination to try and see what these are. Focus, please. So yeah, we got 7555s at the bottom and regular bipolar 555s at the top. Well, that'll do. Let's have a regular bipolar 555. Even though we're mixing bipolar logic and CMOS logic, it's done all the time and it seems to work. Right, so the negatrons come from here and go into pin 1, and the positrons come from the positive rail there and go into pin 8. Kind of. Right, that's a cap. Well, that'll go across pins 1 and 2. No, I'm going to move it down to there because I want a little jumper link to jump between 2 and 6. Right, what have I got in my here and now box? The box of stuff which is just on my desk for doing stuff here and now. There's a little link. Will that jumper across from pin 2 to pin 6? Yes, it will. Look at that. Another 100k pot. I don't know where all these pots go. They must go somewhere because I keep having to get new ones, and I put them in these little breadboard circuits that I make, and then they just seem to disappear. So there's another one. Right, question that is likely to come up. Why don't you connect pin 4, which is reset? It's reset, I think, when you pull it low. So to stop it resetting, you pull it high, connect it to pin 8. Why don't you do that? Why do you leave it unconnected? Well, on the bipolar one, it doesn't seem to matter much. I'm just going to put this LED with integral resistor, 150 ohms, onto pin 3 to ground. Yeah, it doesn't matter much on the bipolar one. On the CMOS 555, it will sort of float all over the place, so you can get spurious resets, but the bipolar one seems to pull itself high without needing to be hooked up. Pin 5, the recommendation is that you put a cap on there, but this is just part of the 3 resistors. You got 1 resistor, 2 resistor, 3 resistor, but all 5k. Some people think that's why this is a 555. It's just, I think, between the top two resistors, it's that point there. Yeah, you can decouple it with a decoupling capacitor, but again, it's just not really necessary. Right, let's just strip that back. Okay, that goes in here like so, and now we can put power to this circuit. Let's stick that in there and that in there, symmetrically opposite. I haven't got any decoupling either, but we don't need that, just for a flashing LED. Oh, that's quite fast, isn't it? Let's slow that down. That's a 1 microfarad tantalum. I've got loads of tantalums. That's why I always use tantalums, just because I happen to have a lot of them. That's slower. Now, of course, you vary the mark space ratio if you just put a pot across pins 8, 7 and 6. So that's probably quite a brief on flash relative to quite a long off flash, but it doesn't really matter. All we're trying to do is trigger the 4017 with some sort of clock, so that'll do. Actually, let's move these down to the end, and then that won't get in my way when I'm trying to build the next part of the circuit. Okay, 4017, let's pop it in. Actually, it might be best over here somewhere, because I'm going to, now these, I never really was into 4000 series CMOS. I was more of a TTL boy myself. Is it ground on 8 and VCC on 16? I don't know. I think I'm going to have to print out the data sheet for that. And that's going to require the use of this. It's my Epson ET2550 printer. And this one's one of these ones that's got ink tanks. It doesn't have ink cartridges. So you put bulk ink in there. And that's a good thing. Well, you'd think it was a good thing until the heads all block up, and which happened recently. But and I did a cleaning cycle, and that just seemed to make it worse. But it seems to be all right now. Right, that should start printing in a minute. Yeah, what happened is I really only use this thing for black and white. I don't really do much colour, so the colour heads or nozzles or whatever they are all blocked up, and only the black and white would work. And as I say, the cleaning cycles just seem to make it worse. But then I left it, what does that say? Printing. Then I left it for about a week or 2 weeks, and it just seemed to come back to life. So, well, that's a good thing. Right, here we go. And so as you do, I tested it by printing a picture of Alicia Vikander, because, well, you would, wouldn't you? Right, here comes my 4017 printout. Right, here is the connections, and we've got VDD on pin 16, that's sensible. VSS on S being source, of course, D being drain. VSS or ground on pin 8. Oh, so that's like TTL. Fine, I'll wire it up. Right, another link wire. And now, which was the clock input? I seem to remember it was 14. Yeah, there's clock input. Oh, we've got a clock enable. Now, is that active high or active low? We've also got reset. Is that active high or active low? Oh, I'm going to have to look up some circuits online. Right, this has got lots of decoded outputs. 10 of them, 0 to 9. Oh, so pretty much any pin, well, any pin on this low numbered side, and the first 3, or 9, 10 and 11 on that side. Let's just stick an LED on there and see if that actually will work without the reset and the what's the name. So any pin on this side will go between ground. Is that the, yes, that's the right way around. No, so that's not, oh, but that's quite slow, isn't it? So it's only going to be 1 in 10 count, but it doesn't seem to be coming on. Let's speed that up a bit. So we presumably need to pull reset down. Well, let's just try pulling them low and seeing what happens. Right, reset's on 15, so that's there. Let's put that to ground. No, that's still not working. Clock enable was 13, so that's there. Let's put, oh yeah, that's kind of working when I, oh, why is that still flashing? That's really weird. What's going on? Something odd going on there. Well, that's flashing. This must be a loose connection. No, there's something really weird going on there. Why am I not seeing that LED, even though this is flashing 1 in 10 pulses? Oh, it's weird. There's sort of strange things happening. What's going on? Right, that seems to have settled down now. I'm not quite sure why it was going to lally, but okay, so more of these outputs. We can put LEDs on. So let's put one on pin 1. And then we should see them flash in a sequence. I seem to be running out of green ones. Let's have a red one. At least I had a consistent process when making these. I always put the resistor on cathode, so that's good. Right, let's put them in there. And now it looks like that's running this way. Does that tie up with the data sheet? Or are all these outputs completely higgledy-piggledy? They are. Yeah, this is classic with 4000 series CMOS. All the outputs are in a completely random order. Great. Well, given the fact that all the outputs are in a random pattern, and 3 of the outputs are up here, the other 7 being down here, I think what I'm going to do is move this CMOS chip right over next to the 555 and move the LEDs out actually onto a bit of blank area here, because the other thing I need to do is put resistors coming from these outputs to the LEDs, and that's because to make the Nightrider effect, which actually moves one way and then back the other, I'm going to use 6 LEDs but 10 outputs and use a sort of resistor matrix to cause this moving backwards and forwards thing. I'll show you what that's all about later, but let's get that 4017 moved down here. Right, there we are. I've moved the chip over to the left. A couple of LEDs just to show that that's working. Now I need 6 LEDs for my Nightrider effect, so let's have 6 of these. Now I don't want resistors on these because, as I say, I'm going to use a sort of matrix of resistors connected to these to make the moving backwards and forwards effect. So I want separate discrete resistors. So let's go and get a load of 100 ohm resistors. Ah, look, I found one of these LEDs which has a long leg there, which you'd assume was the anode, but it's marked with the flat, which is the marking for the cathode. So they've put the plastic on the wrong way round. So I'll just check that one. Long leg to long side of battery, that lights up. So yeah, that one's the wrong way around, but the long leg is still the anode. Which one did I put that one? Long leg to the right. So long leg to the right. Let's put 6 LEDs all in a row. Have these all got the funny thing? No, that one's okay. And then I'll need to take all of the cathodes to ground. So I'll need 6 little pieces of cut-off wire for that. And then we can make this night ride. Right, I've only got 2 100 ohm resistors in my thing, so I need to restock. So I bought 1,000 of in 4 different values. I got 100 ohms, 1k, 10k, 100k. Just so I've always got these commonly used values. So let's cut off a section of those, and that's some 100 ohm resistors. Excellent. Now the end 2 resistors are a special case because they only light. I don't need these 2 actually. Let's take them out. They only light once per cycle, but the 4 middle ones have to light twice. So this one I'm going to light on outputs 6 and 4. So let's see where outputs 6 and 4 are. They are pin 5 and pin 10. Right, so from the anode to pin 5 is 1 resistor, and then another 100 ohm resistor from the, oh, I've got that in the wrong place, haven't I? Let's put that there to pin 5, and in the connector behind to pin 10, which is there. The only thing I haven't done, of course, is linked up a ground for the cathode. So let's put that in and see what happens. Eek, get in. And you can see that it lights twice. Now the thinking behind this is that it lights on the run down towards the left, then that one will light, and then it lights again on the run back towards the right. So that looks correct. It's doing 2 flashes, 1 clock cycle apart. Okay, let's do the next one. This is going to be quite a mess of resistors, isn't it? This one, let's look this one up. Right, so this one is 4 and 6. This one is on output 5, but that needs a different resistor. I'll come to that in a moment. So that was 4 and 6. This one will be 7 and 3. Output 7 and 3. Oh, okay, they're next to each other. They're on pins 6 and 7. Excellent. Right, output 6 and 7. Got to make sure we don't short everything out. It is going to be slightly tricky. Oh, I haven't got a ground on that one yet. Okay, so that's 7. That's 6. That looks good. Let's get a little piece of wire, cut that off to make my ground. Connect that up on camera. You know, I can't get to that very easily, so I'm going to have to do that with pliers. In you go. And you can get a sort of initial sense that we've got something coming down and then going back, but it's not very convincing yet. Actually, I suppose what would be better would be to do this end LED. I suppose I could use 100 ohms, but it's a bit naughty. Let's do it. That really should be 200 ohms because it's unlike these where the resistor is, you've essentially got VCC up here, or VDD I suppose it is, one resistor, another resistor and ground. So it's kind of a potential divider, although it didn't quite work like that because you've got the diode in the circuit. But anyway, let's do this one. This goes to 5. Where's 5? 5 is, oh, it's pin 1. So let's put that LED, I suppose I should do it behind really, onto pin 1. No, that's not right, is it? Because that's got to go to the anode. Like so. This is going to get difficult without shorting all these connections together. And I need another ground link. Let's run the camera when I put this ground link in. Yes. Now we're starting to get a sense of the light traveling down, bouncing off the end and traveling back. Actually, the other end, that LED on the left is a bit brighter, but I've got a funny feeling actually that the current that the CMOS chip can provide might be limited. So these are quite low value resistors. T'other end is 0, isn't it? So 0 is pin 3. Right, the resistor wouldn't reach, so I've had a jumper wire as well. It's a bit of a bodge, but I just want to get this working. Oh no, that's shorting that output to ground. Through a 100k resistor, so that's okay. Let's put it in the proper place, which is there. Oh, I'm making a mess of this. I'm sure you'll tolerate it. That goes in there. See, it doesn't fit in there very well. I think it's the way I've cut the wire. Okay, so that's that end flashing. We just need to get these 2 LEDs done. Awesome. Look at that. We're just missing this one. Oh, now what was it? 6 and 4 outputs. Then it was 7 and 3. That last one was 8 and 2. But it's going to be 9 and 1, isn't it? So 9 is pin 11 and 1 is pin 2. Pins 11 and 2. Let's go for it. Yeah, I thought you'd like to see my agony here because this is really tricky. So pin 11 I can kind of do. 9, 10, 11. If I hop across to there, I'll need a link wire as well. But 2 is going to be really hard. How am I going to get from there to pin 2 without making a right hash of things? Oh, I don't know how I'm going to do that. Actually, I'll bring pin 2 over with a wire. That's the answer. Right, just the ground link for that LED to go. So let's bend that, straighten that up a bit, and shove it in board. It goes there. Now, is that Nightrider? That is Nightrider. I'm just going to listen to the music so that I can sing along. Something like Nightrider, a shadowy flight into the dangerous world of a man who does not exist. This light's a bit distracting, actually. Let's get rid of that. We just want the pure Nightrider effect. I like that. That's looking good. Right, so let's draw the schematic of the Nightrider circuit. And I've got to lay this out in a certain way to make it work. Let's have the 4017 as a big box here. And the 555 is here. Now I'm not going to go into too much detail about the 555 circuit. I mean, you can see how it's wired up. Its output goes into, this is pin 14 as I remember it, which was CLK. Now there are 10 outputs, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have 6 LEDs, so let's draw those. Oh, I'll switch the camera off because this is boring. Yeah, and I've probably done this a bit wrong because I need all this above here, but anyway, these are all grounded. So let's draw that in. I'll put an earth symbol there, so that's ground. Now, the matrix. The end LEDs, I chose to connect to outputs. Let's label these. I'll do them least significant. Well, it doesn't really matter, does it? They're just sequential outputs. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I think I connected the end LEDs to 0 and 5. So 5 will go up to that one. I'm pretty sure that's how I did it. Oh, I forgot my resistors. So let's put 100R in there and 100R in there. Now the tricky bit comes with the inner 4 LEDs. Let me just refresh my memory. Right, so the one connected to 5 is that one. The next one is connected to either side of 5. So it'll be 4 and it'll need 2 resistors. So one resistor there for pin 4 and another resistor there which links onto there for pin 6. So 4 and 6, either side of 5, drive that LED in. That makes sense because you want it to come on just before it reaches the end and just after it starts heading off back the other way. So these are all 100 ohms. Now similarly at this end we want to connect 2 resistors to either side of 0, so that'll be 1 and 9. So we'll have a wire coming up here. We need a resistor, of course, in there. That will go to 1, and we'll have another resistor like so, linked of course, and that will go to 9. My schematic is starting to become as messy as my actual layout. So 1 and 9, now you can see the sort of pattern here. The next ones are going to be 2 and 8. Let's put the 2 resistors in. I've got to fit 4 resistors in here. So those are linked and go to that one, and they go to 2 and 8. This one, what did we have? We had 4 and 6, so moving out from that we got 3 and 7 because those are the only 2 left. Got to try and fit in 2 more resistors. They only just barely fit. That goes to that one, that goes to 7, and that goes to 3. So that's the matrix. It does, however, create these sort of strange potential divider thingies, and I was just wondering actually whether this would work with blue LEDs. Yes, it probably will, because the potential dividers are... Let me draw the potential divider. In fact, before I do that, let's hoik out one of these LEDs and just put a blue one in, because I just want to convince myself that it would indeed work with blue. I'm pretty sure it will. And there it is. Let's take out another red one and put another blue one in, because this one is... That end one, of course, is not on the potential divider. This one will be. And yeah, it's fine. So I'll draw the potential divider and we can see what the issue is here. So let's kind of put the 4017 there. Now we've got one output going to a 100 ohm resistor, and then another 100 ohm resistor effectively going to another output. Now, because the outputs on the 4017, only one is high at any one time, then one of these will be high and one will be low. One of these will be 5 volts and one will be 0 volts. So it's tempting to think that this midpoint will be 2.5 volts, but we've got an LED on here, like so, going to the 0 volts. Let's say that's 0 volts and that's 5 volts. We've got an LED at that point. Now, if you're thinking, well, this is going to create a 2.5 volt point here, and this LED won't light at less than about 3 point something volts, it doesn't quite work like that, because when you've got current flowing through this diode, then this resistor is effectively not really doing anything. Most of the current is going down here and not much is going through here. I think that's how this is working. So we've just got simply 5 volts current limiting resistor. This is 100R. This is 100R. Flowing through the blue LED, this is a light emitting diode, to ground. Well, it works, doesn't it? So let's replace all of these with blue LEDs. So yeah, that works, whether they're blue LEDs or red LEDs. Now, of course, blue LEDs didn't exist back in the 1980s, back in the days of Nightrider. So, of course, the lights on the car were red. And in fact, they were probably incandescent bulbs, because I seem to remember there was a sort of trail it left as it moved backwards and forwards. So they weren't likely to be LEDs at all, really. Yeah, so there it is. A quick and dirty Nightrider. On Breadboard, it's a bit of a mess, isn't it? Actually, I've noticed something quite interesting here. I've got a 1 microfarad. This is about the right speed. 1 microfarad capacitor, 100k pot, and all the resistors 100 ohms. Yeah, all powers of 10. I like that. Cheerio.